Hey, Michael, Vsauce here. What is light?
Like an obvious answer, right? Well, it depends. If you use a Britannica dictionary as a source, then light is electromagnetic radiation that can be detected by the human eye. However, this doesn't quite answer our question. If anything, it brings up more. What is electromagnetic radiation? What is light made out of? And most importantly, why?
Let's start off with the easiest of these questions. What is electromagnetic radiation? Well, you see, electromagnetic radiation is a spectrum, just like how you learned in elementary school that light is a spectrum. Roy G. Biv. Red, orange, yellow, green, blue, indigo, and of course, violet make up the light spectrum. However, just like colors, visible light actually resides on its own spectrum, the electromagnetic spectrum. And light, well, just a small portion of it. You see, only 0.0035% of the electromagnetic spectrum is light that we can detect. To put that into spectrum, 0.0035% of the water in an Olympic swimming pool, which itself has 660,000 gallons of water, would be equivalent to just over 23 gallons. This spectrum, or pool of electromagnetic radiation, consists of 7 main segments. Let's start from the largest wavelength and work our way down. First up are radio waves, and yes, as the name suggests, they are used in radios, as well as a lot of other things. Radio waves are gigantic, some of which are the size of buildings and with their wavelength. But because of their size, they generally have extremely low power and do not cause any harm to humans. Next up on the list are microwaves. Yes, you probably just use one of these to heat up your lunch. However, we're not talking about the machine itself. No, we're talking about what it produces, which are also called microwaves. Microwaves are the next in line to radio waves, but are much smaller, generally the size of an adult human. However, they are slightly more powerful. Now it's time for infrared. Infrared radiation, its wavelength is sadly just too large for eyes to detect, although it is only the size of a needlepoint. This is drastically different from that of the house or buildings as seen with the radio waves, but is still much too large for eyes to detect. Right after infrared is the one that you are seeing right now, visible light. Visible light's wavelength is similar to the size of some microscopic organisms, and as mentioned previously, it makes up an extremely small percentage of the whole electromagnetic spectrum. Ultraviolet wavelengths are just slightly too small for our eyes to detect. However, with the use of UV lamps and other sorts of UV lights, we can use UV radiation to make objects appear to glow. Now here's where things get dangerous. X-rays. Last time you went to the doctor's office, you might have been exposed to one of these things. They are extremely small, but are extremely dangerous as well. In small doses, these things are almost harmless, but if you're exposed for too long, you may end up dying. Up next are X-rays' biggest brother, gamma rays. Gamma rays are extremely lethal. Do not go anywhere near these things. They can penetrate almost any living organism and kill them. They are commonly used in the nuclear field and thus should be treated as dangerous. Well, now that you know about the electromagnetic spectrum, we can move on to the next question we had. What is light made out of? Well, you see, electromagnetic waves are special. They consist of both the electric field and the magnetic field, and as well as a couple photons filled in. The two different types of fields in this wave are transverse waves, and they traverse the plane perpendicular to each other. And much like every other transverse wave, they have a very memorable autonomy. As seen here, the top part is the crest of the wave. This is the peak of the wave, and is the highest point. Slightly ahead of that, you see a huge dip. This is the opposite of the crest, and is called the trough. The space between one crest to another, or one trough to another, is called the wavelength. The area from the resting point of a wave to its crest is called its amplitude. And finally, the amount of wave cycles that occur in 1 second, the wave cycle being defined as a set of concurrent crests and troughs, is the frequency. At the other end, how many seconds it takes to create one wave cycle is called the period. Unlike other waves, light does not need a medium to travel through. This is because it's two different waves that make it a whole constantly propel each other forward. Each one is using the other one as a medium to help it reach its destination. But you may wonder, why? Why does this all matter? Well, you see, without light, you'll always be left in the dark.